we'll be talking about both mixed and entire radicals. But this thing here is a radical. And anything that kind of looks like that, we call a radical, if it has particular parts to it. It has to have an index, a radicand, and a radical symbol. It might or might not have a coefficient. But if it has those three things, index, radicand, and radical symbol, then we call it a radical. So let's start with the easy one. Radical symbol. That's this, the thing that we usually call a square root sign. That's a radical symbol. Sometimes it's a square root, but sometimes, like in this case, it's a cube root, or it could be a fourth root, or some other root. But for it to be a radical, it has to have that sign. And then there are these two other parts, the index and the radicand. The index, oops, radical is the whole thing, sorry. The index is this part here. I mixed up index and radical. Radical is the whole thing. The index is this little number, and it always has to have a little number like that. But we don't always see it. And then it has to have a radicand, which is the part inside the radical symbol. Sometimes it has a coefficient. The coefficient is a number that just goes right in the front. This one has a coefficient of 1, so we don't see it. But those are the different parts that make up a radical. So you're never going to see a radical that doesn't have those three main parts, index, radical symbol, and radicand. If it doesn't have a radical symbol, it's not a radical, obviously. If it doesn't have a radicand, then really it just is a radical symbol of some type, whether it has, whatever index it has. But you do sometimes see them like this, right? Square root of 2. It has the radicand, that's the 2. It has the radical symbol, but you don't see an index. But it actually does have an index. Do you know what the index is?
1.
You would think it's 1, right? Because usually if we don't see an exponent, it's 1. If we don't see a coefficient, it's 1. But it's actually 2. Because the most common root is a square root. And so because it's so common for it to be a 2, we just don't show it. And there's no such thing as an index of 1. So it's the smallest, and it's the most common. If you don't see it, it's a 2. And you will really, this is probably the only time in your life you'll ever see a 2 written in there as an index. And it's just to show you. You won't actually see it.
What does radical mean?
These are two types of radicals. An entire radical is just a radical sign with an index, doesn't say that, but with an index and the number under it. So if I wrote something like root 2, that's an entire radical. And it's called entire because everything is inside the radical sign. There's nothing on the outside. A mixed radical is a number written as the product of another number and a radical. So that would be something like 3 root 2. So basically it's a radical with a coefficient. It's mixed because it has the whole number and the radical part, and the entire radical because it's just the radical part and no coefficient. And what we need to be able to do today is take a number that's a mixed radical and make it into an entire radical, and take a number that's an entire radical, and if possible, because they're not all possible, but make it into a mixed radical, which is basically simplifying it. We're going to take these mixed radicals and turn them into entire radicals. So the way we're going to do that is take the coefficient and move it to the inside of the radical sign. But it's not just moving it inside, because a 5 inside a radical sign looks different. And if we think of those perfect squares from yesterday, the square root of what number is equal to 5? 25, right? because the square root of 25 is equal to 5, we can write this as the square root of 25 and then multiplied by the 3 that's already in there. So the process is going to be square the coefficient and move it inside. And then we'll simplify it. 25 times 3, 75. So this is equal to root 75. Second one here is a little bit different. This is 3 cube root 2. When it's a square root, we just call it root. So the first one I said was 5 root 3, or you could say 5 square root 3. This one is 3 cube root 2. So instead of squaring the number in front, what do you think we're going to do to it? Cube it, right. So 3 cubed is 27. So this is equal to 27 times 2. But don't forget that little index of 3. I still need that there. And 27 times 2 is 54. So it's the cube root of 54.
Can we keep that 3 then?
So that's how you switch a mixed radical into an entire radical. And it is something that you need to be able to do, but it's not something that we're going to do very often because it's not extremely useful. There's kind of only one situation that I can think of where it's useful, so that's what I'm going to do next, is this. Order the following radicals from least to greatest without changing them to decimals. So you could punch it into your calculator if it didn't say without changing them to decimals, figure out the decimal values and figure out which one's the smallest and put them in order from smallest to largest. But this is asking us to do it without a calculator, without changing them to decimals. So instead, we're going to change them into entire radicals because we can't compare them right now. Like when I look at 7 root 3 and 5 root 6, I really don't know which one is a bigger number. Do you? No? But if I take 7 root 3 and I change it into an entire radical, I'm just going to put it there, then it will become the square root of not just 7 times 3, but 7 squared times 3, right? So 49 times 3? And what's 49 times 3?
No, it's not in a calculator. 147.
147. Then if I take the 5 root 6 and do the same thing, I'm just going to move these out of the way for now. Oh, well, just look at this one. Now you can tell which is bigger between these two. 7 root 3 and root 103. Which one is bigger? Right, the square root of 147. So 7 root 3 is bigger than root 103. But you can't tell until you make it an entire radical. So let's do the same with 5 root 6. It becomes root 25 times 6, because it's 5 squared times 6. What's 25 times 6? 150. So now of those two, 7 root 3 and 5 root 6, which one's bigger? 150. Which is 5 root 6 is bigger. Yeah. So we'll do the same with the other two. And then we'll be able to put them all in order. So 9 root 2, 81 times 2, which is 162. And with the last one, we get the square root of 9 times 17, and 9 times 17 is 153. So once we've changed them all, now we can order them. Which one is the least? Because it asks us to put them in order from least to greatest. Root 103. Which one's next? 7 root 3. And then 5 root 6. And then 3 root 17. And 9 root 2. There was really no way to compare those, though, until we change them into mixed radicals. So, like I said, until we change them into entire radicals, I had no idea whether 9 root 2 was bigger than 3 root 17. But now I know that it is, because we put them in a form that we could compare.